So figure 10-43, I said that I'd deal with the preamplifier in a separate video. So I promised to deal with the preamplifier in a separate video, and this is that video. So I'm going to do the AC and DC analysis of this first section. A couple of notes that before you begin that you might want to look for is you'll notice that there's a capacitor across RE. That means that R prime E is the only impedance between here and ground, which is going to give us a relatively low ZIN, but it's going to give us a really high gain. So keep that in mind when we do these calculations. So how the DC is done pretty much like we've done every other DC analysis. So you transfer the parts. So here's R1 and here's R2. You find the Thevenin, the V Thevenin, and the R Thevenin of R1, R2. It comes up 10.8 volts and 3590. You reduce these two guys down to their Thevenin equivalent. Put that into the base drive circuit. So this is the parallel resistance, and this is the Thevenin voltage. Now from that, now that I've got the voltage and the resistance for the base drive, I can plug it into our standard formula. VCC minus 0.7 over RTH plus beta plus 1 RE. Crunch, crunch, crunch. I get a base current of 65 microamps. I'm going to take a bit of a shortcut here. I'm not going to solve for IC and VCE. I'm just going to solve for IE, which is beta plus 1 times IB. Comes out to about 9.84 milliamps. Then I'm going to put that on the graph. So IC sat, 30 volts over 2K, 15 milliamps. VCE off, 30 volts. Plot these 2 points on the load line. Draw a line connecting them. The Q point, so this is 15 milliamps. So the Q point is going to be right about there, which is relatively in the center of the load line, an acceptable point. Now we can look at the AC analysis. So in the AC analysis, I draw the AC equivalent circuit. So I transfer the parts over one by one. Here's the two base resistors here and here. Off of the emitter. Off the emitter. Basically R4 here. R4. R4 has a capacitor in parallel with it, which shorts it out in the AC model. So it's been shorted. And then RC is basically between the collector and the AC ground point. So there's RC. Put the model in for your transistor. Now you've got the DC model. So the R prime E, 25 millivolts over the DC emitter current. I calculated that before in the DC analysis, 2.54 ohms. ZIN is this in parallel with this in parallel with this. 5.6K plus 10K plus beta plus 1 times 2.54, 374 ohms. Let's write that down. 374. Z out, basically this resistor, 1K. Let's write that down. 1K. AV equals V over V in. So V out is, there's the collector current, so it's ICRC. And then Vn is this point here. Vn is this point here. So Vn is going to be this current through this resistor. So that's IE, R prime E. Cancel out the IC and IE. They're pretty much one. Get a gain of minus 390. And there we go. There's the AC equivalent circuit. Sorry, the final AC voltage model of the op amp. I can come along here now and stick a load on here, see what I get out.